This is the Unit 3 Skill 6 video for the equation of a line, and it's the third part of our notes in Skill 6, kind of a long section. And our goal this whole time has been to write the slope-intercept equation given certain kinds of information. So we're going to pause the video. I'd like you to do numbers 1 and 2 as some warm-up examples. Okay, so in number 1, you're given a point and a slope, and in number 2, you're given 2 points that the line goes through. So you can use your notes and complete these two problems, and then we'll compare answers in a couple minutes. So here are the answers to these two problems. Notice in example 1, we plug straight into point-slope form. Remember that whenever you're plugging in a negative number, like y minus y1, it does become a plus sign because of the double negative. As we simplify, we're distributing that 4/5. 4/5 times that negative 5, we treat that as negative 5 over 1, and when you multiply straight across, you get negative 20 over 5, which does give you negative 4. So that's where that minus 4 is coming from. And then finally, I subtracted 1 from both sides to get my final negative 5. In example 2, I first had to find the slope between the 2 points. Okay, and I did my subtraction of the y values in the top, and then I did the subtraction of the x values in the bottom, and I simplified and got negative 1/2 as the slope of the line, and then I chose 1 point. I chose negative 3, 1 as my x1 and y1. I made my point-slope equation and solved and got y equals negative 1/2 x minus 1/2. And you could also have a minus 0.5 there at the end. Now let's take a look at a few other scenarios with different types of information that you could be given to write a slope-intercept equation. So another scenario might be if you're given a point on the line and a parallel line. So what that means is like an equation of a line parallel to the one that we're trying to write the equation for. Let's look at an example. If I told you that our line goes through the point negative 1, negative 4, okay, and then you need slope information, right? But all I tell you is that it is parallel to y equals 7x minus 1. Well, somehow this information needs to help me with finding the slope of this other line. Okay, so let's think of this scenario. If I were to draw a quick sketch of a graph, and I'm trying to graph y equals 7x minus 1, I would start at negative 1 on the y-axis, and I would go up 7 over 1. Okay, I'd have this pretty steep line. Okay, whoops, something like this, okay? Now that line is parallel to the one through negative 1, negative 4, okay? So this other line, if I go to negative 1, negative 4, it's somewhere down here. And so if it's parallel to that, remember they have to look like railroad tracks? So this line, I'll get a different color here, it would need to look something like this, right? It cannot touch the red line. It'd have to be parallel to it, but it has to go through that given point of negative 1, negative 4, okay? So what you might guess is that they have to have the same slope, that same rise over run pattern. If they both go up 7 over 1, then they will never ever touch, okay? So parallel lines have the same slope. Okay, so that's what's important to take out of this. So that means if our line is parallel to y equals 7x minus 1, then our line has a slope of 7. Okay, so we get to steal that slope. Now we have a slope, we have a point, and we plug into point slope form. Okay, so y minus, now our y1 value is -4, so it becomes a +4, equals, this is where we plug in our slope. We now know it's 7 times x minus, now that becomes a +1 because our x coordinate is -1, and now we solve for x. We solve for y. So we get 7x plus 7 times 1 is 7. Bring down the other side. We subtract 4 from both sides. Y equals 7x plus 3. Okay, and so that means that that second line that I drew, it would end up crossing the y-axis here at +3, and it would then run parallel to that other given equation. Okay, I'd like you to try another one just like this. So here's your second example. Follow the steps of the last example and write your slope-intercept equation of the line that goes through 2, -3 and is parallel to y equals -7/2 x minus 3. I'll pause the video and start it in a few minutes. Okay, and here's the worked out solution. So we identify the slope of that parallel line equation as -7/2, and that is the same slope for our line. So notice I put it in that spot for m in point slope form. I plugged in the x1 value and the y1 value and solved for y and got y equals -7/2 x plus 4. Now let's look at our last scenario. So if you are given a point and a perpendicular line equation, that's enough to write the equation of the other line. So let's talk about what it means to be perpendicular. Okay, two lines are perpendicular if they meet at a 90-degree angle. Okay, so if I had a line and another line, that means, and they are perpendicular, they meet at a 90-degree angle. Okay, you could spin that around, move it all over a graph, but if two lines meet at a 90-degree angle, they are perpendicular. And there's something very special and specific about the slopes of two perpendicular lines. Now they definitely are not the same, right? These do not have the same steepness or the same direction at all, okay? But there is a pattern. Let's give these lines a slope. Let's say that this line here, it's going down, so it's negative. Let's say it was going down 3/4, like -3/4. And these are perpendicular. That would mean that the blue line, now its slope is definitely positive. It's going up and to the right. And so if one has a negative slope, the other one has to have a positive slope. And if you just flip the fraction, 4/3, that would then be the slope of the perpendicular line. Okay, so those are called the negative reciprocals of each other. Okay, or the opposite sign, that's the word negative. Reciprocal is the flipped fraction. So let's write slopes of perpendicular lines. Maybe we can just write perp. Slopes of perpendicular lines are negative reciprocals. Okay, that means they are the opposite signs and then the flipped fraction. So let's look at an example here. if I told you that a line went through the point -3, 2, and now instead of being parallel, it is perpendicular to y equals 3/4 x plus 2, and we're supposed to write a slope-intercept equation. Well, we take a look at this slope here, and we're like, okay, if it's perpendicular, they're not the same, but the slope of this line is going to be the flipped version, so 4/3, and then the opposite sign, so negative. Okay, that's all you do. That's all you use this piece of information for. After you get the new slope, you don't use it anymore. Okay, so I write a point slope equation using my -3, 2 and my slope of -4/3. That's y minus 2 equals -4/3 times x plus 3. Okay, that gives me -4/3 x. I distribute the -4/3 and I get -4. And then I add 2 to both sides and I get y equals -4/3 x minus 2. And that's the equation of the line with this information here at the top. Okay, here's one final example for you to work through following this pattern. Here's your example. I'll pause the video and I'll play it in another moment. Okay, here's the worked out solution. My slope that I use is a 3, a positive 3. So when you take -1/3 and you take the reciprocal, it becomes a 3/1, or just 3. And then I make it a positive because I need to change the sign. And so I made a point slope equation out of the point and this new slope that I found. So that's right here. I solved for y and got y equals 3x plus 14. And that concludes this video for Skill 6.